Hi, everyone. Welcome to our talk today. My name is Jonathan Katz. I'm a principal product manager at AWS. I'm also an active contributor to the Postgres community and am involved in a lot of aspects of the project governance, including the core team. I'm pleased to be presenting today with Chirag Dave, who I'll let him introduce himself.
Thanks, Jonathan. Great to be here. My name is Chirag Dave. I'm a senior database specialist, solution architect specializing in RDS and Aurora Postgres. And welcome here. The talk today is What's New in Postgres? All right, so in today's talk, before we talk about what's new in Postgres, let's quickly talk about what's Postgres major release process looks like. So Postgres major release is an annual feature release. So for example, the example shows here, the Postgres 15 release cycle looks like began in last year of July 2021. And then we have a feature freeze, typically in March or April of 2022. And the beta got released on May 20th, 2022. And we plan to have a GA in late Q3 and Q4. So every major version typically lands around Q3, Q4 of that particular year. And we do have minor version for any patches. Those are released every quarter. So when we talk about beta, it's usually very unlikely that any new functionality will be added after the beta is released. So for example, Postgres 15 beta was released a couple months back, and some functionality may be removed based on the testing. So that's typical how Postgres community major release cycle works. Yearly for the major version, and then quarterly for all the minor version or the patch version. So in today's talk, what we'll do is we'll talk about Postgres 14 feature and Postgres 15, which is an upcoming release. So I will talk about the first half of this, talking about Postgres 14, which is already available on a community, also available in RDS and Aurora Postgres. And then Jonathan will come in and talk about what are the new features planned for Postgres 15. So all right, let's get started. So in Postgres 14 at a glance here, was again released back in September of 2021. So it's been a while. It's got a total of 193 features. A ton of features were added in this particular release. And as probably you all know, that Postgres is not owned by any company. It is an open source project, so it's a total community effort, and we have about 400 plus global contributors who have contributed to this awesome release. So what I'll do is for the next 30 minutes, I'll talk about some of the improvements that were done in Postgres 14, and if you're running any older version of Postgres, maybe 10, 11, 12, or even 13, maybe find a good reason for you to upgrade to Postgres 14 and reap the benefit of these new features. So again, as you saw, there were over 150 features were added. So I'm going to try and talk about some of the important ones. That includes the performance. I'll talk about some of the usability improvement that we've done, the improvement around logical replication, some of the improvement in monitoring data, and last but not least, some of the maintenance improvement. So let's get started first with the performance improvement, right? And there were a ton of it. So to get started, the very first improvement I want to talk about is the improvement around the high concurrent volume, right? So before I explain this improvement, let me explain you how the Postgres connection management works. Right? Anytime your client connects to a Postgres server, Postgres will create a fork of a new process. So unlike other database system, which is based on thread model, Postgres is based on a process. So every new connection creates a new process. And when you have too many of these connection, there are too many of the processes. And as the more number of processes gets created, there's always a resource contention where there's a lot of context switching happening. So Postgres does support concurrent connection, but as the number of connection goes higher, you start to see this context switching. And this particular improvement is around how Postgres does the MVCC visibility snapshot. So I'll quickly talk about MVCC. MVCC is a multi-version concurrency control. That's the core of the Postgres, where we have a snapshot for every transaction. We'll have a snapshot of its own data. And because of that, the readers don't block writers, and writers don't block the readers, right? So with this improvement, we expect to see twice the performance boost for higher number of connections. So if you have many connections, and because of the improvement around the MVCC visibility snapshot, you expect to see higher throughput on a Postgres for the higher number of connection, right? So typically, if you expect a higher throughput in Postgres, you would connect more connection, but that's actually detrimental when you start increasing the connection over the number of the max CPU. But if you have a high connection application, this feature certainly will help you. The next feature is, again, a very important feature that was added, which is around the improvement around the B-tree index. So let me talk quickly about the B-tree index. So Postgres B-tree index are nothing but a multi-level tree structure. In that tree structure, you have a metadata, and then you have a leaf pages, and then you have internal pages, right? So the leaf pages are nothing but the pages at the lowest part of the tree, and that contains a pointer to a tuple. So it's an index, so it's pointing to a tuple. So anytime the new leaf page is added to this B-tree index, what Postgres has to do is it has to make a room for that page. So it might create a brand new page for that leaf page. And the process where it creates a new leaf page to make room for item that was originally belonged on the overflowing page by moving the portion of the items to a new page is called page splitting. So essentially, there is a new version of the data. As I mentioned in MVCC, there's always a new version of the data. And if the new version of data comes in, there has to be a pointer. Index needs to be pointing to that version of data. And if we don't have a space, we create a new page and we reshuffle. And there is always this page splitting can cause a cascaded upwards in the tree, and that can cause a lot of bloating. Well, when we talk about bloating, Postgres has a built-in mechanism called vacuuming. So if you look at vacuum does remove this bloat, right? So we have a top-down, the way the vacuuming work is it's a top-down index cleanup performance, and which is triggered by a quantitative label. So what we say in Postgres tuning for vacuuming is we said, if you have n% of the data is dead tuple, then you go and run the vacuum. So it's more of a quantitative approach, and it's a top-down index cleanup that happens. But with this particular feature, what we do is we call it something called as a bottom-up index deletion, which passes through the suspected leaf pages in a more of a quantitative distinction involving logical rows for each version. And each deletion pass is triggered in reaction to anytime that we see a page split or a version churn, right? So anytime we see a lot of version of the data and there is a dead tuple, it automatically triggers this process and proactively will do the vacuuming for you behind the scene, or the index cleanup, I should say. So where does this benefit you? So if you have a workload where you have a small amount of data which you're constantly updating, instead of having the regular vacuum clean it up, the bottom up index deletion will help you and maintain the index bloat. Again, why do you care about index bloat? Again, the more, if you're doing an index only scan, or anytime you do index scan, if you have a large index size, then your performance might be degraded because if you have a lot of bloat. So definitely, if you have in a workload where you're doing a lot of frequent update, this will definitely be beneficial to you. The next one I'll talk about is the improvement around the partitioning and the partitioning pruning. So again, partitioning has been around in Postgres or the native partitioning support is around Postgres since version 10. And since version 10, there has been a ton of improvement in Postgres around partitioning, right? Around partitioning pruning and supporting large number of partitions. In this particular version of Postgres, if you're especially using partitioning, one thing you'll be benefit from the partitioning is that this change greatly reduces the planner overhead for when you have a large number of partition. And the way we do it is by doing a execution time pruning. So anytime you have to do any update or delete on partitioning on any of your partition, it will do a execution time pruning, and that will boost your performance. Next one is extended statistics. So extended statistics has been around in Postgres since Postgres 11, but in Postgres 14, what we have added is a support for Postgres 14 extended statistics for expression. So if you have any expression like average or taking a modulus of data, then you can collect the statistics. Those of you who are not use extended statistics, essentially what extended statistics does is enhance your regular statistics collection. So anytime Planner has to run a query, it looks at the statistics of your data, which is automatically collected by AutoAnalyze. So it's going to look at your table, it'll look at your distribution, and it'll collect the data. And the way the analyze works is it collects the statistics per column. So you have a column A, it'll collect the statistics for A, it'll collect the statistics for B, but A does not know about B, right? If you have any query where you might have some interrelation between A might be A related to B, in those cases, extended statistics can be useful, right? So once you created extended statistics, you have a better input to the planner, so the planner can make better choices. I have a short demo for that following this slide, so I'll talk a little bit more about that in just a second here. And more on the performance, there has been a few more improvement around parallelism in Postgres. So one of them is the parallel scan for foreign data wrappers, foreign table scan, excuse me. So in event, if you're using any foreign data wrapper or, excuse me, FDW, what FDW does is you have a parent or your primary server, which can then connect to a remote node over FDW. You make an FDW connection, and you can have a subset of data in a separate cluster, and you can have that in a multiple cluster. It's sort of a sharding process. So with this feature, you can now run a query on all those FDW nodes in parallel, right? And the other benefit that provides in the Postgres 14 is around the connection management. So in the previous releases up to 13, every time you connect to any foreign node, you have to make a brand new connection. And anytime you make a connection to Postgres, you have to pay price on creating connection. There's a CPU cycle associated with it. So with this Postgres 14 and the way the caching is done for the connection, there's a less overhead on making connection to your FDW nodes, and thus you get a better performance. There's also parallelism was added in anytime you're using PLPSQL functions, which has a return query that can run in parallel, and also refreshed materialized view can also run in parallel. All right, so as I mentioned about the index size improvement, so index size, the index improvement is not just on 14, but there's a lot of index improvement happening since version 11. So what we see in this graph is we have done some PG bench workload, and we've inserted 10 millions of a account table. And you can see in Postgres 11, we have a couple of indexes on the account and on the account BID. And if you look at Postgres 11, 12, and 13, the primary key hasn't changed, but the other index on the BID, IDX, because of the compression in Postgres 13, you see a lot more storage saving there. So just by switching to Postgres 14 on that sample Postgres PG bench workload, you see about 26% improvement over Postgres 11 between 11 and 13. And for the other index, you see up to 77%, right? So depending upon your index and the data distribution, the type of the index, you can see a significant improvement in the index size reduction. Again, index size reduction, meaning less I/O, you'll be paying for less storage, you better performance, right? So it's always a win-win. It's almost a free here. More importantly, if I were to go and update all the records, right? So again, I see up to a 33% reduction in the account P key. And this is what I'm doing is, this is the benefit of a vacuuming that is happening, which is giving you the benefit of giving me up to 33% storage saving in the primary key size here. I just want to show you a quick demo on the extended statistics. So what I'm doing is I have a sample database, and in the sample database, I am creating a table, and I'm inserting some records. And what I have in the data here is that let me just okay. So if you can see my screen here, so what I'm doing here is that while I am first, I'm inserting about 100,000 records, and I am trying to do a float. The way I'm doing the selection of the data is I'm saying, give me the floor of A and a floor of B, right? And when I do that, the planner is running the query fine. But if you notice here, is that there is a estimation of row 25, but the actual return row is about 9,000 or about 10,000, right? And this is because the column A does not have the information about the column B. So selectivity is very poor in this case. So next, what I do is I create statistics on the query that I'm running. So I'm doing statistics on floor of A and floor of B. So I've inserted some decimal value by creating some random numbers here. But after I have this create statistics, after analyzing, I rerun the query. And if you notice this time, the estimated rows is about 10,900, and the actual one is about the same, right? So the point I'm trying to drive here is that with the extended statistics, right, in this particular version, you can use functions, and also you can improve your selectivity and the query performance. In this particular query, it's not very significant because it's just doing a sequential scan. But if you were to doing any join, then Postgres will be armed with a better information to make a better judgment on what kind of join or what kind of sorting it needs to do, right? So if you are struggling with a poor performance on such queries, definitely extended statistics can help you. All right, so next we want to talk about some of the usability improvement. So I want to start with the support for store procedure and the call supporting return data. So talk about that. Let's first talk about, so Postgres supports create function and create store procedures. So create store procedures has been around since Postgres 11, I guess. And the main difference between the store procedure and function is that function returns a result and store procedure does not, right? Up until Postgres 13. So store procedure do support argument like in and out, but not out specifically. And in this particular version, it supports now the out as one of the argument, right? So you can return a value. Where this is going to be important is especially when you are migrating your data from, let's say, or migrating from Oracle or either system where they do support store procedures with a return data type. So now you can have a lesser change to make when you're migrating from Oracle to Postgres. It does require a bit of a application change, but it will be somewhat trivial compared to not having one, right? So if you're migrating from the source system where it uses store procedure with returning data, your migration path will be much more smoother. Begin atomic, again, not a lot to talk about, but very important feature. So begin atomic syntax is really making your user-defined function less error-prone. When I say less error-prone, think of a scenario where you have a function A and function B, and function B is calling function A, right? And if you accidentally remove A, right, and Postgres will happily allow you to remove or drop that function A, but then when you call B, it'll find A is missing and it'll error out, so you'll break your application, right? Up until now. But with the Postgres 14 and the begin atomic function syntax, it improves the dependency tracking for your function. So what does that mean is that if you have function A and function B, if it's defined as being begin atomic, it will not allow you to drop A while the B is there, right? And if you want to drop it, you have to drop it using a cascade, just like you would drop a schema, for example. And because Postgres parses the function during the creation, it can catch additional errors. So pretty important change if you're building application against Postgres. Building on top of it, we have a multi-range data type. So again, range data type, very powerful data type in Postgres, has been around since 9.2, and there's been a ton of improvements since then. Multi-range, again, in nutshell, it's a type of a set of a non-overlapping ranges, right? So unlike array of ranges, they prevent the overlap and thus allow you to effectively model the ranges. And I have a small demo for that, or the screenshot for that, to show you how does the multi-range type works. So I'll talk about that in just a second here. Date bin is for the time series function for aligning timestamp to a specific interval. So it's very similar to if you've used a date trunk in the past, which has been supported for a number of versions already. So what date trunk does is allow you to truncate data of a timestamp to in a bucket of a year or a month or a day or seconds or what have you. Date bin goes further by allowing you to binning by an arbitrary interval rather than just the full unit. So instead of having a year, month, you do bin the data every 5 minutes, every 10 minutes. So if you have any time series function, date bin can be very powerful. And last but not least, the search and cycle syntax. It's a really elegant way of defining any recursive queries, especially if you're using recursive CTEs. All right, so here's a quick screenshot of a sample SQL, which is using multi-ranges. So what I have is, say, you have an employee traveling between multiple cities, and there are some ranges of the stays, right? So what I have is multiple employees, and they are staying between certain dates between different cities. And now multi-range allows you to have this overlapping ranges. So one of the queries that I'm using if you can see on the bottom here, is that I'm selecting an aggregate of stay and grouping by employee ID. And what you see in the bottom is that I can see that employee 1 stayed between 5:10 and 6:1 for this New York stay, and the rest of it is for number 2 employee. There's a bunch of travel in between Boston, LA, Chicago, and Dallas. You can see that range between the 5:12 and 5:14, and the next set of travel was from 6:13 and 6:14. So you get the idea here that you can have a non-overlapping ranges. So again, very powerful feature in Postgres. All right, moving on. I want to talk about logical replication. Logical replication, unlike physical replication, allow you to changes to be streamed to another database independent of a physical file system. So what does that mean is if you want to replicate data between, let's say, 2 major versions, let's say you are trying to upgrade a database from, let's say, Postgres 12 to Postgres 14, you can replicate data physically between 2 major versions, right, because of the structure changes. With logical replication, you can. And some of the use cases for logical replication includes the CDC, if you want to do a change data capture and you want to push it to other system, any BI work that you want to do on a streaming data. As I already mentioned, major version upgrade or multi-writable database, right? You can have 2 database nodes, both writable, and logically replicate against across each other, right? So a lot of great use case for logical replication, and Postgres does support that, right? And as far as the RDS, Postgres, and Aurora Postgres, we do support logical replication as well. So just a quick history of Postgres and logical replication. It's started since 9.4. We started with logical decoding. There was an output plugin was created with a replication slot. That was really an early beginning of the logical decoding process. And then version 10 really, it started supporting natively, where we can logically replicate any insert, update, delete, and can be consumed by a downstream system. In Postgres 13, another important change was done around replication around partition. We talked about the partitioning, right? So with partitioning, you can have replication happening between your partition tables. So instead of parent table partitioning, a parent table replicating data, you can have each partition can replicate logically across a number of nodes. And last but not least, in Postgres 14, the improvement that I want to talk about is the stream in-flight transaction, right? So again, this is another key improvement in Postgres 14 is to improve the in-flight transaction. What does that mean is anytime, again, so what we're doing here is that we are decoding the changes, right? We're converting that into an insert, update, delete, and then we stream the data to a downstream system. So you can have a writer on, let's say, Postgres 13, and you can have a replica on Postgres 14, for example, and we can stream the changes. But you could hit a performance problem when you have a long running transaction. So today in Postgres 13, or at least in Postgres 13, the way it works is if you have a long running transaction, Postgres will start decoding these changes up to logical decoding work mem, which I think it's about 64 MB. So up to that 64 MB, it will start decoding it. And after that, it will start spilling to a disk, right? It will not push those changes to your downstream system until the transaction ends. So if you have a really large transaction, if you're splitting to disk, that will cost you from the performance perspective. But with Postgres 14, we can stream the in-flight transaction over to a downstream system. So for that, I'm going to show you a quick demo here. All right, so here is where I'm going to show you a quick demo of how the in-transaction streaming in logical replication works. So what I'm doing is have a two-node. I have a source Postgres and a destination Postgres. In between that, I'm creating a logical replication, right? So to do that, just going to have some bash script which does everything for me. Essentially, I'm just cleaning up my existing subscription. I create a database for logical replication and make sure that the logical replication is turned on, meaning in RDS world, you have to turn on the switch called RDS.logical replication. If you are using open source, you need to make sure that your wall level is replica. And what I'm doing is that's creating publication and creating a subscription, right? So I'm not streaming any data. But the next part, what I'm doing here is, as you can see on my screen here, is that what I'm trying to mimic is a long-running transaction. So I'm going to do a begin, and I'm going to insert about 500,000 records, followed by an update. And then I'm going to view the status of the replication in the pgstat replication slot. So this is a new view that has been added in Postgres 14 along with this feature. So what you will notice is the stream byte, right? So when I do this, when I apply this change, and okay, let's do this. So when I apply this change, I did the begin, but I'm not committing it, right? So this transactions have been streamed over to my replica. And as you can see here, through my view here is that X amount of stream bytes has been done. On the right side is my destination, right? So the data has been streamed already, but since I have not committed it, obviously you don't see that on my destination. So on the right side, you see that as soon as I commit, my data will be available, right? So again, powerful feature when it comes to using logical replication, and when you have a long-range transaction, your performance will be much better with Postgres 14. All right, moving on, I want to talk about some of the monitoring improvement. So one of my favorite one is to uniquely track the Postgres query through the pgstat activity. So you might have used the pgstat statement as an extension, very powerful tool to do any Postgres query performance analysis, which shows you, what are the most frequently running queries, where you're spending time, and so on and so forth, right? So now we, the community, have added another field on pgstat activity called a query ID, which kind of allows you to look at which queries are running, and then you can start to group by based on that query ID and start to understand which one is your most impactful queries. I have a quick screenshot on the next slide, so I'm going to talk about that in a little bit here. On the monitoring improvement, you have progress reporting on copies. If you're running copy command, it will show you how much the progress of the copy statement is. So unlike insert, you can in Postgres, you can use copy for a bulk load into your Postgres. I already showed you the replication slot statistics, the one we were just talking about. So there is a improvement in the replication slot statistics. And one of my other favorite one is the write head log wall statistics, right? So I have a screenshot for that, and I'll talk about that in a second here. So here you see a PG stat activity where you can see that there's a new column that's available called query ID. And as you can see here is that if you look at update on, and this is some synthetic PG bench workload that I'm running, and if you look at PG bench, update to PG bench account has a unique query ID of ending with 4598, for example. Any other account changes will have the same query ID. For example, the branches one has the one with 907, and the 907 repeats here, right? So to look at the query regardless of what the arguments are, right? And then you can start to group by and look at any performance bottleneck query for you. And the last screenshot I want to show you is the PG stat wall. Again, very powerful view, which kind of show you some deeper level metrics on how the Postgres wall is doing. So for example, you can see Postgres FPI, which is the full page write, right? So anytime we do a checkpoint in Postgres, after the checkpoint, Postgres has to do a full page write. So it kind of shows you how much of the full page write you're doing, or the important metrics around the wall buffer full. So how many times the wall buffer will full? In my case, it was 2,000 times. So maybe this gives you an idea that maybe your wall buffers are too small and maybe you need to tune it. So anytime you're doing any replication, if you're loading a lot of data, generating a lot of wall files, this view can be really, really handy, especially understanding the number of full page writes and how the buffer is doing. Last but not least, some of the maintenance improvement. The important one is the emergency vacuum mode, right? So if you're using Postgres, you know about the wraparound, which is essentially you need to vacuum. Every time Postgres write or any transaction it does, there is a transaction ID is attached to it, and there is a finite number of it, which is the 4 billion. Right? So anytime you're doing a transaction, there's a 2 billion value considered to be in the past and the next 2 billion in the future, right? So you need to vacuum before the wraparound occurs. We do have a mechanism. There's a mechanism where Postgres will start vacuuming to avoid a wraparound at certain threshold. There are parameters to allow you to set that. So at that point, it'll start doing a vacuuming to avoid a wraparound. What this feature gives you is another tuning parameter called vacuum failsafe age and vacuum multi-transaction failsafe age. Essentially, what it's saying is that, I am running wraparound, but I have reached this threshold. So at this point, what it's going to do is it's going to drop all the cost-based vacuuming. So the vacuuming is a cost-based process. So it's going to try and do the vacuuming as fast as it can to avoid that wraparound failure, right? So again, another helpful tuning parameter to avoid having that wraparound accident. There's been improvement in the analyze page prefetching. So the analyze can do prefetch and give you better performance when you're running analyzing, and analyze important for your query performance. And last but not least, really this is more of a performance improvement, but again, important to call out here is that we've added a LZ4 compression for the toasted table. So toasted table, real quick, is anytime you have a Postgres writing to a page, typically by default it's the 8K page, and Postgres does not allow you to have a tuple span across multiple pages. If you have a variable length data, you could increase, and you could potentially have a data higher than that value. In that case, Postgres will try to compress it and put it into multiple pages, right? And that's really a toast for you. Up until Postgres 13, we had a PGLZ as a compression algorithm, and Postgres 14 introduced LZ4, which has better compression. You expect to see better performance while you insert data to this toasted table, even when you select, right? So good little improvement. This setting could be at the global level. You can even set it at the table level or the column level, right? With that, ton of fun stuff that you already can start using for Postgres 14. But what I want to do is I want to pass on to my colleague Jonathan to talk about Postgres 15. So at least it gives you visibility of what's to come. And if you're interested, you could already start testing. So without ado, Jonathan, passing it over to you.
Thanks, Chirag. As Chirag mentioned, Postgres 14 is already available today, and you can try out all of those features on Amazon RDS for Postgres or Amazon Aurora Postgres Compatible Edition. So let's look ahead at Postgres 15, which is still in development. We're actually in the beta period right now during this presentation, but we'll look ahead and see some of the features that are coming up and what you can try tomorrow in Postgres. First, a few fun facts about Postgres 15. There's over 150 features in Postgres 15, which is quite a lot, and we don't have time to highlight all of them. So this is just going to consolidate the features that are available and give you a sense of what Postgres 15 can do for your database workloads. The target time for the general availability of the Postgres 15 release from the Postgres community is in late September, early October. That's typically when the new major versions come out. Of course, those dates are subject to change based upon what happens during the beta period, and if a particular feature needs more work, or the community has processes to help decide this. But you can get a preview of the release notes, from that link below, and that link ultimately becomes the release notes once Postgres 15 comes out. So let's dive a little bit deeper and see, see the features that are coming out as part of Postgres 15. So what are the performance enhancements available in Postgres 15? One of the major ones is just improved in-memory store performance, and actually improved store performance in general. Postgres has this thing called working memory, which helps perform certain operations within memory itself, sorting being one of them. If a sort gets too big, or if you have to pull in too much data into that working memory, this can spill over to disk, and that's when you do the sort on disk. What's nice about Postgres 15 is that there's enhancements to both, that there have been some optimizations to the sorting algorithm within memory, as well as if a sort exceeds the working memory, optimizations to that algorithm. Some tests have seen 100% improvement. Some tests have seen as much as 371% improvement. And what's really nice about this is that you can ultimately get this for free. Like, this is part of just a general order by query in Postgres. You might need to tune your working memory parameter based upon the data that's going in, but you're basically getting these enhancements just by upgrading to Postgres 15. Some other things to highlight, the Postgres FDW, or the Postgres foreign data wrapper, now supports parallel commit. Backing up a second, if you're not familiar with the Postgres foreign data wrapper, it basically is a way for you to federate your data or access your data across multiple Postgres instances. It provides an interface that looks just like a Postgres table, but it can query tables that are not on your current Postgres instance, but other instances. So uses are for data federation, aggregating data across distributed workloads, or even sharding systems as well. The enhancement in Postgres 15 is that you can now commit transactions in parallel to multiple systems, all from within the same query. This builds upon the feature from Postgres 15, where you can query across different Postgres instances asynchronously using the foreign data wrapper. As a fun fact, Postgres actually supports a bunch of different foreign data wrappers that let you query other database systems, in addition to the one that lets you query other Postgres systems from one Postgres instance. There's also an optimization for high CPU core ARM64 processors. In fact, you can see noticeable speed up for processors of 48 plus cores. Postgres 15 also has a bunch of usability enhancements that improve the developer experience. One of them could easily be a talk in itself, just on the merge command. So, before talking about merge, a little bit of a background in terms of what this is and why this feature is important. What merge does is that it lets you do conditional SQL, or the ability to say, like, hey, based upon this condition, do an insert, but if I have this condition, maybe do an update. Before Postgres 15, there were a few ways to do this. If you want to do the equivalent of an upsert, also known as, if something occurs, insert, but if there's a conflict, do an update, that exists since Postgres 9.5. It's the insert on conflict statement. If you want to do any other type of conditional SQL, you'd have to write a store procedure or a stored function. And while that's certainly helpful, there is overhead to that. Postgres 15 introduces the merge command, which is part of the standard SQL syntax, and it allows you to do any sort of conditional SQL involving insert, update, or delete from within the query itself. This is pretty cool. One way to look at it is that it's ETL in a box, or extract, transform, load in a box. One thing to note when you're playing around with this is that the merge command does pull everything into working memory, and your performance can be affected by how much data you need to pull in in order to perform the merge. So you might need to play around with it depending on your particular query, but you can certainly see performance on par to doing an insert on conflict based upon what your data set is. The next thing to highlight is SQL JSON support. Postgres actually was one of the first, if not the first, relational database to support storing JSON within the database. This was as far back as Postgres version 9.2, which came out in 2012. The SQL JSON standard, or a standard interface for being able to manipulate JSON data within a relational database, was published in 2017. Postgres has now adopted a lot of the SQL JSON standard, and in this release, adds a lot of support for fundamental functionalities such as constructors, inspecting the JSON data, seeing what's inside, and querying it. Now, none of that is new in Postgres. As I mentioned, Postgres has supported this functionality for a long time, but now you can interface with your JSON data using the SQL JSON standard. This is good for interoperability, working with tools that have built out functionality around the SQL JSON standard, etc. The new thing that Postgres 15 adds is the JSON table function. I think this is really cool. With the JSON table, basically you can take your JSON data and turn it into a table, turn it into a relation where you can query data against it. In my career, I've run into situations where I had the JSON data within Postgres, and ultimately that data I needed to query very actively, and I needed a way to convert it into a table. This allows me to do it directly from SQL, where I can take that JSON data, map it into the relational format, and then insert it into a table somewhere. There's also additional functionality for working with regular expressions, which you can read more about in the release notes. Chirag mentioned some of the compression improvements in Postgres 14, and Postgres 15 builds on that. In general, Postgres 15 added support for the Z standard, or the ZSTD compression algorithm, and Postgres 15 adds support for the full page writes and the write-ahead logs that Chirag mentioned, both for LZ4 and Z standard compression. You can also now compress your PG-based backups on the server side with a choice of gzip, LZ4, and Z standard compression. Let's look a little bit more at the wall compression experience in Postgres 15 from some benchmarks. So let's look at this data in terms of how Postgres wall compression works with the three different algorithms available. So this benchmark was run with pgbench, a utility that comes with Postgres, using a scale of 2000. The system was a 16-core system with 128 gigs of RAM, and was limited to 3,000 IOPS just to create an IO bottleneck. Before discussing the results, note that this can vary based upon your workload. So in this particular workload, these are the results, but you do need to test it for your own workload to see which compression algorithm makes the most sense for you. So you can see that from this graph that the transactions per second improved, particularly once the number of connections grew. And we can see that the compression certainly helps to improve the transaction. If we look at the pre-Postgres 15 numbers, just between the PGLZ algorithm and not having any write-ahead log compression, you can see that there is a performance improvement. But there's a more noticeable performance improvement with both LZ4 and Z standard, for this particular workload. We can also see some space savings as well. So using the same exact benchmark, we can see that without compression, as you would expect, the data is going to take up more space. But each of the compression algorithms did show performance improvement. And in this case, we see a 71% improvement between having no compression in LZ4, and PGLZ does have some a little bit more space savings, again, for this particular workload. We can see Z standard has the most space savings. And for this particular workload, it seems that Z standard makes the most sense, both from a performance and a space savings trade-off. There's a few other improvements in this area as well for Postgres that are worth calling out. The first is being able to write archive modules for write-ahead log archiving. When you're archiving write-ahead logs to an external system, such as Amazon S3, Prior to Postgres 15, you have to specify something called an archive command. An archive command is a program, a shell script, or something that gets executed in the shell. With that, there is overhead because Postgres has to essentially create a shell session every single time it runs the archive command, and there might be potential security concerns with that. With an archive module, you're basically extending Postgres to be able to perform the archive activity, and it can run natively within Postgres. So that eliminates the overhead of being able to create the shell, and you should expect greater performance from that. There's an example of an archive module available with Postgres 15. Postgres 15 also adds something called wall inspect, which is an extension that lets you look at wall archives through a SQL interface. Now, prior to Postgres 15, you can inspect your physical write-ahead logs using a tool like pgwalldump, but it could be a little bit challenging to interpret. Now, you can be able to look at your write-ahead logs directly from SQL. So this is pretty cool, and it's a much more convenient way to be able to inspect what's going on within your physical write-ahead log archives. Postgres 15 also improves logical replication, similar to Postgres 14. There's a few things to note here. Postgres 15 adds the ability to filter rows and columns from a logical replication publication. So you might choose to only publish a subset of columns, or you may choose to filter out rows that you don't want replicated over. For instance, if your source table has, let's say, test data, you can filter out all the test data to make sure only the non-test data is being streamed over. There's a few other niceties as well. For instance, you're able to skip conflicting transactions without recreating a subscription. So if there's a conflict on your subscriber and you want to move on to the next transaction, you're able to do this with the alter subscription skip command. You can also automatically disable a replication stream on conflict. Previously you could manually do that, but now you can automatically do that with Postgres 15. You can also publish all tables within a schema versus publishing all tables within an entire database. Few security highlights from Postgres 15. By default now, the create privilege is revoked from everyone in the public schema, except for the database owner in new databases that are created. This is in response to actually an old CVE 2018-1058, where it's possible for a user to create a function in the public schema that looks similar to a catalog function, but could potentially have malicious code in it that, if executed by a super user, could do some very bad things to the system. This helps mitigate the risk of this attack playing out. This attack does involve multiple parties in it, but it's better to limit the risk of it. So by revoking the create privilege by default from the public schema, it reduces the surface area for someone to be able to execute this attack. There's also something called a security invoker view now available in Postgres 15. This is really neat. Prior to Postgres 15, Postgres views are security definers. What does that mean? Basically, it means that the privileges, the view has the privileges of an owner or the person who created the view. And when you execute the view, it executes it with the privileges of the owner. So if it's the owner of the view is a super user, you're executing the view as a super user. With the security invoker, when you execute the view, you're executing it as the person executing the view. So even if, say, a super user created that view, you're not executing that view with the super user privileges. So that adds just a little bit more security around who and what is accessing and modifying the data. A couple of other general highlights, the JSON log format. So I'm kind of a nerd for this one, but this basically gives Postgres the ability to do more advanced structured logging. Structured logging, you see it in a lot of systems, particularly Kubernetes, where you might have logs filled with JSON data that you need to offload somewhere. Being able to do that and analyze it, with a structured format such as a JSON log makes it much simpler, and you're able to extract even greater insights from it. So I'm very excited for this new feature. I can't wait to try it out and put it into any of the systems that I'm managing. And the ability to inspect configuration much more simply from PSQL or the Postgres command line. This is with \d config. This allows you to, by default, just look at your non-default Postgres configurations or any settings that you've changed. But you can also grep and search for configuration names. Typically, when I'd have to do that, I'd have to search the Postgres documentation or go in a search engine and look for it. But now I have a way to start looking for configuration more easily, using Postgres 15. So let's summarize what we've learned today. So let's see what we can do today with Postgres 14. We see that there's performance improvements for everyday work, particularly if you have a lot of different connections coming from your system. You should see improvements to your throughput. There's more opportunities for parallelism, through parallelized, materialized views, being able to return parallel queries from functions. And through that, you can also get greater insight into your query performance. I'd say in particular with that query ID that's passed around through a few different of the query tracking views. And there's more tooling for app builders to make it easier to write applications. I'm very excited for the ability to use the begin atomic function declaration. I've certainly been bit in the past by deleting a function and then not knowing that it was called 3 layers later in the stack. And some things, to take away, just from this early preview of Postgres 15 is that there's significant work spent on simplifying the developer experience. You can see this through something like the merge command, where it's much simpler to write conditional SQL queries, and adding things like the SQL JSON syntax or having the ability to turn your JSON data directly into a table. There's more space-saving options and even throughput improvements for both backups and archiving, and much more flexibility with logical replication, particularly when getting yourself out of a jam if you have a conflicting transaction. There's also general improvements that help with daily tasks. Even something like JSON log, where you're able to analyze your data, more easily, or your logging data more easily through structured logging, certainly has improvements and may help you, better understand what's going on with your Postgres workloads. And thank you again for attending. Chirag and I both had a lot of fun today talking about what's new in Postgres and what's coming in Postgres. If you have any questions, if you've joined us live, please feel free to ask them now. And thank you again for attending.
Yeah, thank you, Jonathan, and thanks everyone who have joined. Looking forward to hearing from you. Thank you.